Okay. This week's material. Okay, this week we are doing numbers and their operators. The material is available on Blackboard. We also have the open book quizzes. At 1.4.1, that's the open book quiz for number systems and operators. We also have an open book quiz for 1.4.2, operators and constants. Okay, now we're going to go through numbers and their operators. From the previous work, you learned what integers are. This week we are learning what a float is, what floating point numbers are. So integers, they're non-empty decimal fractions, which means, in short, it's whole numbers, like 1, 2, 3, 4. And floating point numbers, this is when we have a number with a fraction like 1.2, 1.3, 10.5. What's important with floating point numbers when you're writing a program in C++, make sure that when you declare floating point number, don't use commas like 2,5. Use points like full stop. 2.5. That's the rule for writing floating point numbers. If you write commas, you will get errors. Yeah, sure. So these two numbers here will show you the difference between an integer and a float. That is, an integer, it doesn't have any point, and it doesn't have any number after a point. This is a float, 4,0. 4.0. We're not using commas, remember. If you want to write large numbers, instead of writing this long number, 300 million, in maths or physics, you'll usually just write 3 times 10 to the power of 8. But in programming, we use 3e8, which is 3 to the exponent 8. The e means 10 to the power. 3 times 10 to the power of 8. Yeah. It can be small letter, it can be capital letter, it doesn't matter. So we saw when we want to declare integers, we use the keyword int. In the case of floating point numbers, we use the keyword float. There's an example here. Here we declare an integer I. We use int I. Here we declare a float x. Float x. And this example will actually show you the accuracy between the difference in accuracy between integers and floating point numbers. If you write a program that will divide 10 by 4, divide integers, two integers, 10 and 4. 10 divided by 4 here, you will get 2. Because we are calculating integers. Since integers don't contain the fractional part, your answer will just be 2. But if you're calculating floating point numbers, 10.0 divided by 4.0, you'll get an answer of 2.5, because now that is a float which contains the fractional part of that number. Then operators. These are the symbols we use in programming. We have a symbol for multiplication, which is an asterisk. If we want to do multiplications, that is how we do it. K times, that is a times. J, asterisk. Division, we use a /. And remember, never divide by 0 in programming. You'll get errors. Addition, we use the normal plus sign. And subtraction, we use the normal minus sign. Unary minors. I can say basically it's when we want to specify if a number is negative. If you want to declare a negative float, you just say minus 10, 10.5. And same for positive numbers. Instead of a minus in front of the number, you can put a plus sign. If you want to find a remainder of two numbers, we use this percentage sign symbol, which is a modulo. And remember, if you want to find a remainder of between two numbers, when you divide two numbers, you cannot use this with floating point numbers in programming. It only applies with integers. If you want to find a remainder of 10 divided by 3. In priorities, this is when you're doing arithmetic operations. There's operators that have high priority. Like I think you know in maths, there's before you do any calculations, if there is brackets anywhere, you have to remove brackets first. You have to do some addition, then some multiplication, and stuff like that. The C++ language have a left-sided binding. This means when doing calculations in C++, you start from the left to the right. If 2 plus 5 equals 7. This is the list of priorities. Unary operators, plus or minus, where you specify a number if it's positive or negative. Times, divide, and modulo have the same priority. And then lastly, you have the binary, which is when binary means 2. You're adding two numbers, or you're getting the difference between two numbers. Parentheses. They say sub-expressions in parentheses are always calculated first, just like we discussed with the brackets. If you have a calculation with brackets, always remove brackets first. That also applies in programming. If you want to write a program that increments any value by 1, you can use either of the two ways. There's a counter equals to counter plus 1, which means we are adding 1 to that counter, or we can say counter plus plus. This will give you the same result. This is just a shorter version of that. Same with subtraction. Instead of writing all that, holidays equals to holiday minus 1, you can just say holiday minus minus, which means you subtract 1 from the number of holidays. The plus sign is called an increment operator, and the minus sign is a decrement operator. As we've seen from the top, we are decrementing there. So there's pre and post operators. Pre, which means we use the sign before the variable. So here's an effect. You increment or decrement the value first. You increment the value first, then you can use that variable for pre-operators. In post, you use that variable first, then you can increment or decrement. Small example. This is our updated table for our priorities. Now in unary we have increment, decrement, plus, minus. Those have the same priorities. And the binary operator, and that is an assignment operator, which when you find your answer for your calculations. Shortcut operators. Shortcut operators. Just instead of writing I is equals to I times 2, is that correct? If you yeah, if instead of saying I times I equals 2, you can just say I times equals 2, which is a shortcut for I is equals to I times 2. There is a table with examples of shortcut operators, and that's it for this PDF. I have another. Sure. Then operators and constant. I think most of what you get here, it's additional information to build up on numbers and operators. So in here we learn what is a literal. If you have a value of 5, it's still small. Literal just means if you have a value of 5, the value of 5 will never change. 5 contains that value of 5. That is the literal value that number has, 5. We all know what 5 is. You don't know what 5 is, come on. So there's more on integer numbers. There's more on floating point numbers. Characters and string literals, you'll also learn that in the next unit. But you should also read this because you will find questions from there. Escape codes, how to print a new line, use \n, how to print a tab. You can also read more on that. Then operators, there's more, there's additional information on operators. These are the arithmetic operators we looked in the previous module, addition, subtraction, and all that. There's also examples. You can do this code in NetBeans and see how it works. We also looked at incrementing and decrementing. Logical operators, did you do digits? I'm sure you all did digits by now. I think I'm good. There's a nice table here that summarizes everything with operators. There's also description. Okay guys, that's it.